So we are still multiplying polynomials. You still get to choose between distribution and the box method, but technically there are some special products. So I'm going to be really general at the moment, but what if I asked you to multiply a plus b squared?
You distribute the 2 to the a and the b.
That would make my heart really sad if you distribute the 2 to the a and the b.
It would be a squared plus b squared, right? Oh, a third, a cubed plus
a plus b, and then again a plus b.
Yes. So if you go back to our exponents unit, like day 2, we talked about what a plus b squared means. It means a plus b times a plus b. It means you have 2 sets of what's in the parentheses. Listen carefully, and some of you probably should make a note to yourself. You are not allowed to distribute an exponent in if there is an addition or subtraction sign. You are not allowed to distribute an exponent in if there is addition or subtraction signs.
Don't we do that when we distribute the expressions?
An exponent?
Yeah, like, it's like that would be like negative 2x, and then you distribute like the 2 in, like, say, like that.
Right, but there's no addition or subtraction sign in there.
Wait, what?
So,
Isn't the negative kind of?
hold on, watch. So like something like this, right? We attach the 2, but there is no addition or subtraction sign.
So, like, what if there's a negative? That's just
Well, that just means negative 2. It doesn't mean plus or minus. Okay? So if there is a plus or minus in between your terms, let's put it that way. So if there's a plus or minus in between your terms, you are not allowed to distribute that 2 in. Now, some of you aren't paying attention right now, and some of you are going to give me the answer of a squared plus b squared, and I'm going to be really sad when you do, and then I'm going to be sadder when I have to give you a 0 because you didn't follow directions. Okay? You are not allowed to distribute a exponent in if there is a plus or minus.
Are we making that into standard form?
We will, yes. So let's look at an actual problem. So if I gave you x plus 4 squared, because I will give you a problem that looks like that, and I want you to multiply, what do you think the first thing you should do is? Rewrite it. X plus 4 times x plus 4. And do you know how to multiply x plus 4 times x plus 4?
Yes.
Yes. You distribute or you use the box. You choose. Okay, so choose whatever method you're going to do and do it. Distribute or box. I'm going to distribute for this one. So x times x gives me x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. So it is exactly what we've been doing, other than the fact it won't necessarily be written out as 2 sets of parentheses, and you need to make sure you rewrite it before you do any kind of multiplication. Can you handle that?
Yep.
Yeah? Okay. So what if I gave you and this is our general one. What if I gave you and asked you to multiply a minus b squared?
This is
What would you do?
when you multiply these,
Okay, but what would you do first? Like how, Ethan? First step, you need to write that sucker out, and you should have 2 sets of parentheses. Okay, a minus b times a minus b. So, for instance, let's look at x minus 5. Actually, let's make that a 2x minus 5 squared. Let's throw something else in there. So let's do 2x minus 5 squared. So your first step should be 2x minus 5 times 2x minus 5. And then you can apply distribution or the box to it to actually multiply it out. When you multiply 2x times 2x, you get 4x squared. 2x times negative 5 is negative 10x. Then negative 5 times 2 is negative 10x. And negative 5 times negative 5 is 25. So you should have gotten 4x squared minus 20x plus 25. Both of these are known as perfect square trinomials. Okay, perfect square trinomials. Why do you think it's a perfect square trinomial? What makes it a perfect square? Okay, what makes something like a perfect square root? There's no decimals. So, like, give me an example of something that's a perfect square root. 16. The square root of 16 is 4. So you'll notice here that my two second terms are the same. If I multiply them together, I get 16. If I take the square root of 16, I get 4. Eventually, in the next couple units, actually I think it's the next unit, we're going to start with a trinomial like this, and we're going to work backwards and do something called factoring to get these terms. Okay, so we're doing like the first part and seeing what it looks like, and then we're going to work backwards in the next unit. All right, this one might be your favorite because you do get a trick with this one, which is a whole lot less work for you if you can remember the trick. And I know how much work you don't like doing. However, if you forget the trick, guess what always works? Distribution or the box. Okay, so if you don't want to remember the trick or you forget the trick, the distribution method or the box will always work. So what do you notice about this one in comparison to the other two? Okay, one's plus, one's minus, but my first term is A and my second term is B, right? So that means they're the same before the plus and minus and the same after the plus or minus. This is going to be important for us later, but this is known as difference of squares. Okay. Difference of squares. And this one takes the least amount of work. Okay? Your answer will be a squared, so whatever a is, it could be a variable, it can be a number. So a squared minus whatever b squared is. Okay, I'm going to show you. Okay, so it's going to be whatever a is squared and then whatever b is squared, and it's always going to have a subtraction sign. So for instance, we're going to look at x plus 3 and x minus 3. Okay, so x plus 3 and x minus 3. Now, without doing any work, I can tell you the answer is x squared minus 9. Okay, so let's see how someone said yes. So someone caught on to the trick. So let's look at the trick first, and then we'll prove it by either distribution or the box. So the trick says a squared, so my a term is x, right? You're really just multiplying x times x, which is x squared. And you're multiplying 3 times 3, which is 9, and it's always going to have the subtraction sign. Why do you think there's no middle term? Okay, so I want you to distribute or use the box right now and solve that and figure out why there's no middle term. Like, what happened? Why did these ones have 3 terms and this one only has 2? What's going to happen? So distribute or use the box and see what happens. Okay. Are we figuring out why there's only 2 terms instead of 3? Okay, so if I distribute, I get x squared plus 3x, and then I get, I'm sorry, it should be a minus 3x there. I did mine backwards. Try again. So x squared minus 3x, and then I get a 3x minus 9. So those middle terms are canceling out, leaving me x squared minus 9. So if what's in your parentheses is exactly the same, where one's a plus and one's a minus, you multiply the first 2 terms together and you multiply the last 2 terms together and you call it a day. If you forget the rule or the trick, you use the distribution method and the box and see that they cancel out. Okay, so let me give you one to try. And I don't care if you use the trick. I don't care if you distribute. I just care that you can do it. Okay, so you can either use the trick or you can distribute or use the box. How many people went straight to the trick? Okay? And if you didn't, that's okay, because you're going to get the same answer. But because what's in both sets of parentheses is exactly the same, except one has a plus and one has a minus, I'm going to multiply my first 2 terms. So 2x times 2x is 4x squared. And I'm going to multiply my last 2 terms. 7 times negative 7 is negative 49. Because those middle terms, which would be a 14x and a negative 14x, cancel out. Yes?
Can you still do the trick even if like the numbers like didn't work the same?
No. Because it won't cancel.
Okay.
Okay, so it has to, they literally have to be identical except one's a plus and one's a minus. Everything else has to be the same for it to work.
And if it wasn't, then
You
you
just-
just do the box.
Yep. And if you want to check yourself, so if you're not like 100% sure if the trick's supposed to work, distribute or use the box anyway. Okay, let's look at one more, and then I will give you your homework. Okay, theoretically you should be done, right? Because you're noticing that what's in the parentheses is exactly the same. One's plus, one's minus. So y times y Y squared, 8 times negative 8 is a negative 64. Okay, so a lot of multiplying in this unit, and then some combining like terms and adding and subtracting. But that's it. We have one more lesson tomorrow, but it's just an extension of multiplying and combining like terms. So if you can do those, adding, subtracting, and multiplying, those three things, this first test should be solid for you. Okay, but you should don't get overconfident and not double check your work, because you're going to be upset with yourself if you add, subtract, or multiply wrong and make silly mistakes. Right?